Hello, my name is Mr. Asprey, and this is my EDEXCEL A-Level Maths 2026 Predicted Paper 2 version 1. My most favourite time of the year because this is the time where we can make the biggest gains, given that we have done paper 1, we've got an idea of the topics that have come up, and now it is time to press on with paper 2. But please listen to this intro. I'm going to say 3 things, really important you listen to them. Number 1 is, of course, massive disclaimer. As we know, there's no guarantee these topics will come up on paper 2. It's so important that you revise thoroughly. Number 2, and that is that I've compiled 2 more versions of my predicted paper 2, and I'll be walking through those in my live session. Now, they have completely sold out, so thank you so much for those students that have purchased and are coming to the session. If you would still like to access all the resources, including a recording of the session, written solution to all 40 questions, video solutions to all 40 questions, then you can click the link in the description. And then finally, number 3, make sure you download this from my Google Drive, version 1 for free. Download it and do it yourself before watching the video. Give it a try, see how you get on, and then watch my solutions afterwards to check to see what you got right and to pick up some tips along the way. I've made hopefully the questions at the start relatively more straightforward, and at the end we've got some absolute beast questions. So enjoy. I hope this is really good, helpful revision for you. If it is, please do like the video and subscribe. And I will see you in the maths. Let's get into the maths, is what I meant to say. Let's get into the maths. Let's go. Okay, we've got small angle approximations, and we'll start off with part A. But actually, first, what we'll do is we'll just remind ourselves of what the small angle approximations are. And that is that sine theta is equal to theta. Cos theta is equal to 1 minus theta squared over 2. And tan theta is also approximately equal to theta. Now, those are given in your formula sheet, or formula book, sorry, so you don't need to memorize those. Okay, so now we are asked to work out 2 cos theta plus 1 minus tan squared, or tan theta squared. So we can say this is approximately equal to, and then do our substitutions. So we know that cos theta is 1 minus theta squared over 2, plus 1 minus tan is theta, and then that's squared. Okay, so let's multiply the brackets. So we get times through by 2 gives us this, and this is a squared bracket, so we'll do double brackets, which will give us 1 minus 2 theta, and then plus theta squared. Okay, so these 2 can cancel. So one's positive, one's negative. So we get 2 plus 1 is 3. And then minus 2 theta. Perfect. Okay, and then on to part B. And it says, hence determine the approximate solution to this, which is exactly the same thing that we said was approximately 3 minus 2 theta is equal to 28. So we can say that 3 minus 2 theta will now approximately equal 28. And sine theta, again, because we're working in small radians here, sine theta is theta. Okay, so therefore 3 is approximately, add the 2 theta over, gives us 30 theta. Divide through by 30 gives us that theta is approximately 0.1. And of course that must be measured in radians. And that is it. Perfect. Okay, we've got vectors, and we're going to start off actually by just writing out each of the vectors as columns, because I know that a lot of students don't like using the i's and j's. So I will, I'll do this. So we're going to get, and be careful with this one because there's no j components. We've got to put the 0 in the middle to represent no j. And then OC is going to be 7 minus 4 minus 2. Okay, now we're looking for the midpoint m, because it's asking us to find OM, the magnitude of it. So we need to know what m is. Now m, as a coordinate, is just simply the average position of the i's between b and c, and the j's and the k's. So the average I position, and we've got b is -1, and we've got C is 7, so we take the average by adding them together and dividing by 2. And then we'll do the same for the J's, and we'll do the same for the K's. Okay, great. So this gives us the coordinate of M, which is going to be, that's going to be 3, that's going to be -2, and that's going to be 2. So therefore we can say that the position vector of M is just that coordinate written out as a vector, which looks like this. And then the magnitude of OM is going to just be using Pythagoras, because to find the distance or the magnitude of a vector, you take each of its components and you square, and then you add them together, and then you square root, and that will give us root 17. Perfect. Okay, now for part B, whoops, didn't write part A. For part B, it says that the point D is such that BC is equal to AD. Okay, so the fundamental, most important vector sort of equation or formula, I guess you could call it, is that is to be able to write a vector between two coordinates by their position vectors. And the way you do that is B to C is the same as OC minus OB. And A to D will be OD minus OA. And then after that, we can just simply use what we know and just substitute in. So that's 7 minus 4 minus 2 minus OB, which is -1, 0, 6, is equal to OD. We don't know that, but that's what we're looking for. And OA, we know, is 3 minus 4, 2. Okay, great. So let's simplify this side first. So that's going to give us 8 because of the minus minus. That's going to give us -4, and that's going to give us -8. And that's equal to OD minus this. So therefore, we can say that OD will be that left-hand side, but we need to add over that vector. So plus this vector, because it was subtracted from that side, so we need to add it over to the other side. And then we can do that, which is going to give us 11 minus 8 and minus 6. And then because the question is in i's and j's and k's, we're going to want to convert back to i's and j's and k's. So that's 11i minus 8j minus 6k. Perfect. I've got some simple modelling going on here, and it says that exactly 3 years we have that the tree was 2 meters, and after 5 years it was 2.4 meters. And now, really important for any modelling question, always check the units, don't gloss over that information. Meters is the same as what we've been given, great, and years is the same as what we've been given, so it's absolutely fine in this instance. Now this is the equation, and we've got to find those constants, so we're just going to substitute into that equation. So we'll start with the yellow information. So it's 2 cubed is equal to p times by t, which is 3 squared plus q. So let's simplify that. So that is 8 is equal to 9p plus q. Can't do any more with that, so we'll just box it up, and we'll move on to the next bit of information, which is the blue bit of information, and that is that the height is 2.4. So we'll cube that, and that's equal to p multiplied by 5 squared plus q. Okay, we'll simplify, or not simplify, yeah, we'll simplify that. That's what we'll do. 2.4 needs to be cubed, and that gives us, indeed, 13.824 is equal to 25p plus q. Okay, now we can't do any more than that. And we've got 2 equations, so 1 and 2 we're going to solve simultaneously. Okay, so 1 and 2 we need to solve. And it doesn't say anything about not using a calculator here, so we are pretty much good to go into equation, simultaneous equation, 2 unknowns. Whoops, that is what? 2 unknowns. Oh, there we go. Did I click 3? Okay, so we have the p's will be the x's, and the q's will be the y's, and that's equal to 8. And then we've got 25, we've got 1, and we've got 13.824. Click execute, and there we have it. It wants it to 3 significant figures. So we can say that the p is equal to 0.364. And then the next one is the q, which is equal to 4.724. Perfect. And I've just noticed, though, that it does say 3 significant figures where necessary, so I need to get rid of that 4 there. And now I can box them up as my answers. Okay, perfect. And now for part B, it's saying that the height is 5, work out the time. So we just substitute in 5 as for the height. So we get 5 cubed is equal to P, which is 0.364 times by T squared, and then plus Q, which is 4.72. Okay, great. So that gives us 125, and then we're going to subtract the 4.72, and that will equal this. So then we just divide through by 0.364, and that will equal t squared. And then we can just simply square root both sides to find t. Okay, and then we can put it in our calculator. Okay, so the answer is 18.2. It does say here, find the value of t. So it's not actually asking for the time, so we don't need to give units. We just need to find the value of t, which is exactly what we've done. So that will be our final answer to 1 decimal place. Okay, we need to use the factor theorem to show that 2x plus 3 is a factor. Well, by the factor theorem, if 2x plus 3 is a factor, then f of whatever solves that. So quickly we do 2x plus 3 equals 0, minus 3 to both sides, and then divide through by 2. So that's what we can substitute in, and if that equals 0, then we know it's a factor. Okay, you must do this if it says use factor theorem. Okay, if you do something like polynomial division here, you are not going to get the marks. Okay, so that needs to be squared. Okay, and then we get this, and then we get this. Now, I'd also want to do some evaluating here. I wouldn't want to go just straight to the answer of 0. So I'll do minus 1.5, and then I will cube it and times it by 6. Okay, so that gives me minus 220.25 for the first term. And then I will do minus I'll do minus 1.5 again. Actually, if I square it, it's just 1.5 squared, and then times it by 17. Okay, so that gives me plus 38.25. I mean, it is a show that question, so I do want to put this extra bit of effort in. This will be minus 6, and that will be minus 12. Okay, and now it's okay for me to say, yeah, equals 0. And then even still, we've not completely finished. We say hence, as f of minus 3 over 2 equals 0, then x plus 2x plus 3 is a factor of f of x, not just a factor, because a factor of what? No, a factor of f of x. Okay, so maybe I'm being a bit pernickety here, but I do not want you to lose this mark because it's such an easy mark. And I see students lose these marks because they don't write a conclusion, and also you just want to evaluate a few of the terms because it is a show that question after all. Okay, now it says, hence, using algebra, find f of x as a product of 3 linear factors. Well, this is now when we do our polynomial division. So we need to be doing 2x plus 3, we know it's a factor, so we know it divides the polynomial perfectly. And the polynomial from above was 6x cubed plus 17x squared plus 4x minus 12. Okay, so how do we do polynomial division? Well, we look at this lead term and this lead term, and we divide them. So 6x cubed divided by 2x is 3x squared. And then we multiply that 3x squared by the divisor. So 3x squared times 2x is going to be 6x cubed. And 3x squared times 3 is going to be plus 9x squared. And then we draw a line and we subtract. Okay, so these terms here will cancel as by design. And 17 minus 9 is going to be 8. So it's 8x squared there. And then these ones are going to come down as well because we're not taking anything away from them. Okay, now we look at a new line, which means we have a new lead term, which is 8x squared. And we ask ourselves, what do we get when we divide that by 2x? Well, that gives us 4x. So multiplying down is going to give us 8x squared plus 12x. Yep, when I times the 4x by the divisor here. And then we can subtract once again. And these are going to cancel out. 4x minus 12x is minus 8x. And then the minus 12 is going to come down again. And then finally, we've got a new lead term. So we need to divide that by 2x. And that gives us minus 4x. No, just minus 4. So that'll give us, and then when we multiply the minus 4 by this, we get minus 8x, and minus 4 times 3 is minus 12. Perfect, they line up so that when we do our final subtraction, we get 0, which means there's no remainder, which means it is a perfect factor, as we knew from the factor theorem. Okay, great. So now we can say that f of x is equal to this original factor multiplied by what we got when we divided. So 3x squared, and then we had plus 4x, and then minus 4. And then we can split that into 3 linear factors by factorizing this quadratic. So by inspection, we're going to assume it's 3x and x, and we're going to get minus 2 and plus 2. So that will be plus 2 because that will give us then 6x. And if that's a minus 2 in there, take away 2x from 6x gives us the 4x. Perfect. Okay, so that's us splitting it up. Perfect, so that is our final answer. So I'll box that up. And then we will move on to part C. And it says solve between pi over 2 and pi the equation, bloody, 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 blah. Now that is very similar to this. In fact, the only thing difference is that x has been swapped out for tan theta. Okay, so what we can say is for part C, which I'll do down here, x equals tan theta. And if we solve this equation here, so we have 2 tan theta plus 3 multiplied by 3 tan theta minus 2 multiplied by tan theta plus 2 equals 0. So we've swapped out the x's for tan thetas. So therefore tan theta is equal to minus 3 over 2, or tan theta is equal to 2/3, or tan theta is equal to minus 2. Okay, so in radians, we need to work out what these are going to be. So for this one, we're going to get as such, and in fact what it might be useful to do actually is work out what the range is, because the range said it was between pi over 2 and theta and pi, which means we're somewhere in the region of about 1.52 and 3.14. Okay, so 1.57. Okay, so this first answer is no good, but of course with tan we can always add pi to our solution. So if I add on pi, Still getting used to this calculator. We get that, and that is in the range. So we can say that is 2.15. Let's go 2.159. Okay, and then for the next one, we can go shift tan of 2/3, and that gives us 0.588. That's outside of the range, and if we add pi to it, that will still be outside of the range, so that's actually no good. And then the next one, -2, so we can do shift tan of -2, and we get -1.11, and then again we can add pi to get our second solution, like so, and that is good. Yep, that's inside the range. So we get that. So these are our final solutions then. Just double check how many 3 significant figures. Okay, perfect. So this is good to 3 significant figures. And this one, we just need to round it up to put a 6 there. And then that will be good to 3 significant figures. Exponential modelling, and a hot piece of metal is dropped into cool liquid. As the metal cools, the temperature blah, 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 is modelled by this. Find the temperature of the piece of metal as it enters the liquid. Well, when it enters the liquid, of course, T is equal to 0. That's little t at the time. So capital T is equal to 300 e to the 0 plus 20. And that's equal to 320, because anything to the power of 0 is 1. Then times by 300 and add 20 is 320, and that is in degrees Celsius. So it says find the temperature, so I must give the units there. It's not asking for the value of T, it's asking for the actual temperature, so I need to give units. Okay, great. Now, part B, it says find the value of little t, so I wouldn't need to give units, for which capital T is equal to 180. Giving your answers to 3 significant figures. Okay, so it seems to me like I just need to substitute in 180 for capital T. Set that equal to 300. And that'll be e to the minus 0.04 t, and then plus 20. Okay, great. So let's just get solving. So we'll minus 20 from both sides, like so. We'll divide both sides by 300 to get 8 over 15 is equal to e to the minus 0.04 t. And then when we've got an e to the power of something equals something else, we take lns of both sides, like so, and then that will remove the e and bring the power down, like so. And then, well, we can either divide by minus 0.04, but what happens when you divide by minus 0.04? You times by 25. Okay, so we're going to get minus 25 ln 8 over 15 is equal to t. Perfect. And then it's asking us to give t to 3 significant figures, so we just need to literally put this into our calculator. So it's minus 25 ln of 8 over 15, which gives us an answer of 15.7. That's 3 significant figures, and it just said find the value, so I don't need to bother putting the units in. We just want the value of t. Perfect. Okay, next it says show by differentiation that the rate in degrees Celsius per minute at which the temperature of the metal is changing is given by this expression. Okay, so we know what we need to do. We need to differentiate the formula. Okay, so this is the formula, so we are going to differentiate that. Okay, so what I'll do is I'll just write it out again. So t is equal to 300 e to the minus 0.04 t plus 20. like so. And then when we differentiate, this is going to give us dt by dt. And when we differentiate an e function, then it is going to go exactly to itself, but the derivative of the input will multiply out because of the chain rule. So multiplying through by minus 0.04. So we take our 300 and we need to multiply by minus 0.04. And that gives us minus 12. So it becomes minus 12 e to the minus 0.04 t. And then the 20, that's going to go to 0. Okay, perfect. Now, we need to write this in a particular way. We need to write it like this. Okay, so what we're going to do is we're going to make, we're going to take our formula here, and we're going to rearrange it so that e to the minus 0.4t is the subject. And that way we can substitute it in over here. Okay, so let's just draw a little line down here. And let's say that t minus 20 is equal to 300 e to the minus 0.04 t. And then divide through by 300 gives us this. Okay, now that can go into here. So we can say that dt by dt is equal to minus 12 multiplied by this thing here, which is t minus 20 over 300. Okay, great. And now if we do 12 divided by 300, we get 1 over 25. Great. So we know it's going to be over 25. And then the negative here is going to multiply into here, and it's just going to switch them round. So it's going to be 20 minus t because of the negative. Perfect. And that is our final answer. Lovely. Question 6, and we've got log modeling. Now, with all of these questions, I always start by looking at the formula and then just taking logs of both sides. So we do log, and this is in base 10, because we can see here for all these base 10s, of p is equal to log base 10 ab to the power of t. We then just keep on going, and we write that we log ab to the t could be split up into log a plus log b to the t, given that if you have log of two things times together, it's the same as log of the first thing plus log of the second thing, using our log laws. Okay, and then what we can do is we can bring the t down like so. Again, using log laws, if we've got something to the power, then that could come down to the front, become the coefficient of the log. Okay, and then what we're going to do is we're going to look at the variables in the equation. And the variables are log p and t. So I'm going to write log p on the left, because a straight line would be y. And then I'm going to write, remember t was that other variable, so I'll write log base 10 of b times t, because that variable will be our x, and therefore log b will be m. And then plus log base 10 of a, which is that, just move it to the other side, and that will be our plus c. Okay, great. So just doing that now tells us exactly what the gradient is and what the intercept is. Because if we line up the non-variables, you can see that the gradient is log b, and we can write the gradient is equal to log 10 of b, and we also know the gradient is 0.09. Now, writing this as a power equation rather than log one, the base is 10, the power will be 0.09, and that will equal b. Okay, so we can do 10 to the power of 0.09, and that gives us 1.23. What does it say? To 2 decimal places? Perfect. So we can box that up as a final answer. And then we can turn our attention to the other constant. Log A is the same as the intercept. So we can say that the intercept, which is equal to log base 10 of A, is also equal to, again from the information, 0.68. So writing this as a power equation, we can say that 10 to the power of 0.68 is equal to A, and then we can put that into our calculator, 0.68, and we get 4.79. And that will be also one of our final answers. Okay, moving on to part B, and it says, in context of the model, give a practical interpretation of the constant A. Well, whenever you've got a model like this, P is equal to A times by B and then to the number of years, where B is the multiplier, so what you're multiplying each year by. And in this case, A is, well, 4.7, what was it, 4.79. Okay, so it's like compound interest. You start with an initial amount and you times it by a multiplier for every year that you wish. Now, P is the percentage of the population who have access to the internet, and therefore A is the starting amount, so it's the starting percentage. Okay, so what we'll write is, we'll write this. We'll write this. This is what we'll write. Here we go. Represents the percentage of the population who had access to the internet at the start of 2005. Okay, then it says use the model to estimate the percentage of the population who had access to the internet at the start of 2015. Well, what we said is the formula was P is equal to 4.79 multiplied by 1.23, and we need to do that to the power of 10 because there's going to be 10 years between 2015 and 2005. So we take this amount, we might as well just take the whole amount and just times it then by 1.23 to the power of 10. Okay, great. And we get, to estimate the percentage, we'll say 37.9%. And given that it doesn't say what to give it to, we'll do it to 3 significant figures for our final answer. Question 7, we've got a classic log equation. Now we're going to start by rewriting the log that has a coefficient, and we're going to use the log law, which tells us that if there's any coefficient in front of the log, we can raise the input to that power. So it becomes 1 minus x squared, like so, plus 3. Okay, great. Now we're going to move our logs to the same side, because then we can use another log law to simplify them. So we're going to minus like so. And when you minus 2 logs, it's the same as dividing their inputs. So we're going to have 32 minus 12x over 1 minus x to the power of 2, close brackets, is equal to 3. Okay, now we've got a logarithm here, so this is just a log equation, which we can now write as a power equation. This is the base, so 3 is the base. This is the power, so 3 is the power, and then this is what it will equal. So we can say 32 minus 12x over 1 minus x squared is equal to 3 to the power 3, also known as 27. So we can write 27 there, like so. Okay, right, next step then is to multiply up. So we get 32 minus 12x is equal to 27 lots of 1 minus x squared. We could then multiply out those brackets. It's a double bracket. we'll get 1, and we'll get a 1 times minus x, and another 1 times minus x, so minus 2x, and then a minus x times a minus x gives us a plus x squared. Okay, great. So we can just carry on solving by multiplying out the brackets further still, like so. We can then bring all to one side. So we'll get 27x squared. We'll write that first. And then we are adding on 12x to the minus 54x, which gives us minus 42x. And then we are subtracting the 32 from the 27, which gives us minus 5. Okay. Annoyingly, we can't do any simplifying there. So we're just going to go to our calculator because it doesn't say anything about we're not using calculator technology. And we're just going to solve this quadratic. So it's 27 minus 42 minus 5, and hoping for some nice numbers, of which we get. Great. So that is 5/3 and minus 1/9. Now, whenever you solve a log equation, you must check to see if the ones are valid. And in fact, let's look here to see which ones will be valid. So we must have inputs of logarithms be positive. Okay, you cannot have a negative input into a logarithm, which means that 32 minus 12x needs to be greater than 0, which means that 32 needs to be greater than 12x, which means that x needs to be less than, there we go, 32 over 12. Like so, which both of them are, to be fair. Okay, well then what about this? We need this one also to be positive. So we need that 1 minus x needs to be greater than 0, which means that 1 needs to be greater than x, which means that x needs to be less than 1. Okay, perfect. There we go. So in order for both of these to be satisfied, only the minus 9th actually satisfies both of them, because this is the only one where x is less than 1. So we must reject this one here. Perfect. Okay, we've got the binomial expansion, and we will need to get the equation from the formula book. Okay, so here it is. Now, in order to use the equation, it needs to have a 1 in this slot here, but at the moment we've got a 4. So we need to bring that out to get started. Okay, so we're going to say that 4 minus 5x to the power of minus a half is equal to, now if I bring that 4 outside of the bracket, that's perfectly fine. It means everything inside is going to get 4 times smaller, like so. But if you ever take a factor out of a bracket that's raised to a power, you must bring that power out with it, like so. Okay, great. So what we can do is say that 4 to the minus a half is a half. Okay, and then we can open up a big bracket and we can apply this formula. Now, in order to apply the formula, actually, what I like to do is I like to say that the power is minus a half of the bracket, and the x isn't actually x. It's actually been changed to minus 5 over 4x, like so. Okay, so how far do we have to go? It says up to the x squared term, so we just need the first 3 terms. Okay, so the first term is 1. So we just put 1 there. And then the next term is n times x. So that's minus a half times by x, which is minus 5 over 4x. And then the next term is n times n minus 1. So that's minus a half times, if I take 1 away from that, it'll be minus 3 over 2. And then x squared is minus 5 over 4x squared. And then all of that needs to be divided by 1 times 2, which is just 2. and then we'll close the bracket there. And what we'll do is we'll just quickly change that to approximately equal to, because we've not used all of the terms, so we're just using the first three. Okay, so that's a half. Let's simplify all this up then. So we've got 1. We need to do all this on our calculator perhaps, or maybe we can just do it in our heads, because there's 2 negatives make a positive, and we're going to have 5 over 8x. And then maybe the next one I'm not going to do it in my head. So let me just do it on the calculator. Okay, there we go. As you can see, put it into the calculator. So it's 75 over 128, and that'll be x squared. Okay, perfect. And then all we need to do now is just times through by that half. So we get 1/2 plus 5 over 16x, and then plus 75 over 256 x squared. Perfect. That will be our final expansion up to x squared. Great. So now we look at part B, and it says that, oh, wowza. So we've got this function, which the bottom bit is exactly the same as that, because the negative power puts it at the bottom and the half power square roots it. So all we need to do then is times our blue expansion through by this, which is 2 plus kx. So let's get that set up, and let's say that f of x is equal to 2 plus kx times by our expansion, like so. Whoops. Okay, and then let's see what they're asking us to do after that. Well, it says here that when we do this expansion, we know we're going to get a 1, and we're going to get a 3 over 10 for x. So given that we know this coefficient, they told us that coefficient, let's find what the x coefficient is when we expand out our bracket. Well, how are we going to get to the x coefficient? Well, we'll do 2 times by the 5/16 x, but also we'll do k times by a half, because that will also give us an x coefficient. So in doing so, we get 2 lots of 15 over 16 x, and we'll get kx times by a half, and all of this will equal our 3 over 10 lots of x. Okay, great. So this is 5 over 8x plus k over 2x is equal to 3/10 x. We can now cancel out the x's because there's an x on each term. So we'll get that k over 2 is equal to whatever 3/10 minus 5/8 is. So we can just do that quickly on the calculator. So 3/10 minus 5/8. Okay, so therefore k over 2 is equal to minus 13 over 40. So times that through by 2, and of course we get minus 13 over 20. So k is equal to minus 13 over 20. Okay, perfect. And then now it's asking us to find the value of m. So m is the x squared coefficient. So in order for us to get the x squared coefficient, we're going to need to multiply down these lines. We're going to need to do an x times by an x, that will give us an x squared, or a constant times by an x squared will give us an x squared. So that'll be 2 lots of the 75 over 256 x squared, and then plus the other one will be kx times by 5 over 16 x, and we said that that's going to equal mx squared, as you can see there. Okay, so that's equaling mx squared. So let's simplify this up. So timesing through by 2 is going to give us 75 over 128 x squared. k we know is minus 13 over 20, and we need to times that by 5 over 16. And that gives us minus 13 over 64. And then the two x's times together to make x squared, of course. And that's equal to mx squared. Once again, we can now cancel out our x squareds. So we can find what m is just by doing 75 over 128 and then minus 13 over 64. Okay, great. So we get 49 over 128. Perfect. Okay, we've got a recursive sequence, and we are going to start off part A by finding U2 with or without U. Okay, so U1 is 1. We're going to substitute that into the sequence, which tells us the next term along in the sequence. So it's going to be 2 minus 3 lots of the previous term, which we said was 1. So 2 minus 3 gives us minus 1. Okay, U3 is going to be 2 minus 3 times by the previous term, which in this case is minus 1. So 2 and then minus 3 times minus 1 is 3. So it's 2 plus 3 is 5. Okay, great. There we go. So that's just literally just subbing in to the sequence formula. And then we can move on to part B, which is asking us to find the summation up to the fourth term, when r is 4, starting with r is 1, of r minus the sequence ur. Okay, well actually, in order for us to do that then, we need to first work out what u4 is, because we're summing up to the fourth term. So let's just move that down slightly and write here u4 is equal to, again, 2 minus 3 lots of the previous term. So that would be 2 minus 15, so that would be minus 13. Okay, now what on earth is this asking? Well, it's saying start with r is equal to 1. Okay, let's do that. When r is equal to 1, we have 1 minus u1. And then it say keep adding up to when r is 4. Okay, so when r is 2, it's 2 minus u2. Where the streets have no... Sorry, I'm going to stop singing U2 songs. And then when r is 3, it's going to be 3 minus u3. And then when r is 4, it's going to be 4 minus u4. So we could just substitute in, probably the easiest way of doing it. You could perhaps split up the summation if you wanted to, but I think this way, because it's only 4, this is nice and simple. And we're just going to substitute in, so 1 minus 1, and then u3 we said was 5, and then u4 we said was minus 13. Okay, perfect. So we get 0 plus 3 minus 2, and that will be plus 17. So in total, that is 18. Cracking. Apologies for the singing. Okay, beast question here. Lots of reading, which I don't like. In a large theatre, there are n rows of seats, and the number of seats in the first row is A, and then each subsequent row, there are 4 more seats. Okay, so this is an arithmetic series, and clearly we are adding on 4 seats each time. So D is equal to 4, and A is the first row, which is the first term, so A is just A. The number of seats in each row form an arithmetic sequence, given that the total number of seats in the first 10 rows is 360. Well, that means that the summation of the first 10, so S10, is equal to 360, but we also know from our formula that it's equal to n over 2, 2a plus n minus 1d. But given that we're summing up to 10, we know that n is 10, so we can put a 10 there. And we also know n is 10, so we could put a 9 there, because n minus 1. Perfect. And then we're told that that's equal to 360. Okay, so we can simplify this. That's 5. 2a, we said up here that d is 4, so 9 times 4 is 36. And that's equal to 360. Okay, we can then divide both sides by 5, which gives us 72 on that side. So 2a plus 36 equals 72. So 2a is equal to 36, so a is equal to 18. Perfect. Oh, that was part A. We get 18. Okay, great. Now let's move on to part B. It says, given also that the total number of seats in the n rows is 2146, show that n squared, blah, 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 blah. Okay, well, that's another summation because it says show that the total number of seats. So Sn, once again, is n over 2. It's 2a, but we know that a is 16, plus n minus 1d, but we know d is 4. And we're told that's equal to 2146. Okay, great. What we can do then is, we could get a bit fancy here. I'm going to apply that divide by 2 into the bracket. So that becomes 18, because we're cancelling out the divide by 2 and the times by 2. And also here, this term, we need to divide by 2. So rather than timesing by 4, we're timesing by 2. So it gives us 2n minus 2 when we expand that out. Okay, so just multiplying in that divide by 2 into those two terms inside the bracket. Okay, so we can then say n, and then we have 2n, and we've got 18 minus 2 is 16, like so. We can then expand this, and we can also minus over that, and then we can divide through by 2 because it's equal to 0, and dividing by 2 gives us 1073. Perfect, and that is as required. Lovely. Okay, so moving back up, hence state the number of rows of seats in the theatre. Find the maximum number of seats in any one row. Okay, so we can solve that, and we can do that on our calculator. Doesn't say anything about not using calculator technology here. So we can solve this. So 1, 8, and minus 1073. Okay, so this gives us then, for part C, part 1, n is equal to 29. And is there a second solution? Negative. So we can just ignore that. Obviously, n is the position in the sequence, so it has to be positive. So that's just going to be our answer. Number of rows is 29. And then part I, the number of seats. Well, the greatest number of seats will be in the 29th row, given that d is 4, so it's positive, and the number of seats are getting bigger every row you go back. So we can say that the term, which represents the number of seats in the 29th position, will be a plus n minus 1d, where n is 29, of course. Okay, because that was the equation for the nth term. And we know that a is 18, so that becomes 28, and we know that d is 4. So we just need to do that calculation, and we should be good to go. So 18 plus 28 multiplied by 4 gives us 130. Great. So 130 seats. Okay, we've got a circles question, and we are going to start by saying IA. and it says find the coordinates of the center of the circle. Well, in order to do that, we need to complete the square. So we write the two x's next to each other and the two y's next to each other, and then we keep that constant term k over on the other side. We'll complete the square, so we take the 10, the number of x's, and we half it, and then we write in brackets x plus that squared, and then we minus that value squared. And let's do the same for the y. So we half this number here, so half of minus 12 is minus 6. So we say y minus 6 squared minus, and then that number again is minus 6 squared, and that equals k. Okay, great. So we can say that's x plus 5 squared plus y minus 6 squared, and then this minus 25 here goes to the other side, and this minus 36 goes to the other side. So adding on 25 and 36 will give us 61, and then there's also k there as well. So we can therefore say the center of the circle is equal to minus 5 and 6, because the equation of the circle states that x minus a squared plus y minus b squared is equal to r squared, where a and b are the center of the circle. Okay, now part B, sorry, says finds the range of values of k. Well, what we know about the radius, it must be positive. So r squared must be greater than 0 because r is greater than 0. So r squared is 61 plus k. That must be greater than 0. So therefore k must be greater than minus 61. Okay, it can't equal 0 because then again it wouldn't be a circle, it would just be a dot. Okay, next, it says that the point P0, and the point Q, minus 210, and the point R, 18 minus 14, lie on a different circle, C2. We know that P is positive and that QR is the diameter. Find the exact value of P. Well, let's say we have this other circle, and we know Q, and we know R, and we know that it is the diameter. It means that we can then work out the midpoint, which will tell us the center of that circle, which can be very helpful. And then once we have the center of the circle, we can then work out the radius of the circle as well, which will give us the equation of the circle, and then we can sub in, and that should be able to allow us to find out what P is. So quite a bit of work to do. Let's start by working out the midpoint between those two coordinates. Okay, so part II, we need to find the midpoint of those two coordinates. Okay, so I've just put the two coordinates there because I've forgotten what they were. So midpoint of QR is going to be the two x coordinates added together and then divided by 2, and the two y coordinates added together and then divided by 2, which will give us 3, and it will give us minus 2. Perfect. Okay, so now we can work out the radius, and the radius will be the distance from the midpoint to the one of the coordinates. So the distance formula is the change in the x. So why don't we do let's do r and the center. So the change in the x will be 8 minus 3, and that needs to be squared, and then the change in the y will be minus 14 minus 2, and that will need to be squared as well. Perfect. So we can calculate that. Just scroll down a bit. We can say that the radius is going to therefore equal the square root of 5 squared plus, that will be minus 12 squared, which is just the same as 12 squared, and that's just going to give us 13 because that's a Pythagorean triple. How nice. Now this can tell us exactly what C2 is. So we know that the formula for a circle is x minus a squared plus y minus b squared is equal to r squared. So we can say x minus the center point, which for the x is 3, as you can see here, squared plus y, and then minus 2, so that would be plus 2 squared is equal to r squared, and r's 13, so that squared is 169. Okay, so now we know the equation of the circle. We can substitute in the point P0 because that is on the circle, so it should satisfy the equation of the circle. So we're going to sub in P0 into C2, and that's going to give us P minus 3 squared plus y, no, y0, so it's just plus 2 squared is equal to 169. So that gives us P minus 3 squared plus 4 is equal to 169. So P minus 3 squared is equal to 165, like so. And then we can square root both sides to get plus minus the square root of 165. And then we can add the 3 over, and we get this. Now, it did say above that P was a positive constant, so P is greater than 0. Therefore, P is equal to 3 plus the square root of 165 for our final answer. Perfect. Okay, we've got rates of change. We need to read these questions very carefully. It says shows that a right circular cylindrical rod which is expanding as it is being heated. At the time t seconds, the radius of the rod is x and the length of the rod is 6x. Given that the cross-sectional area, so not the whole like surface area, but the cross-sectional area of the rod is increasing at a rate of that. So that information we can write down straight away. So because it says that the rod is increasing, the cross-sectional area is increasing, we can say dA by dt, because whenever it says rate, that means with respect to time, and we're going to call the cross-sectional area just A, and that's equal to pi over 20. And then it says find the rate of increase of the volume when x equals 10. So we are trying to find the volume's rate, which is dV by dt. Okay, all we know so far is just this dA by dt. But what we can do is we can work out that the area is equal to, or the cross-sectional area at least, is equal to pi x squared, which means we can work out dA by dx by differentiating that, which gives us 2 pi x. Okay, well, what else can we work out? Well, given that we're trying to work out the volume, it would be quite useful to know what the volume was and then differentiate that. So the volume of a cylinder is the cross-sectional area, which is pi r squared, multiplied by the distance, how far back it goes, or the height, depending on, well, whether or not it's on its side or if it's stood up. But anyway, that's what it's going to equal, and that's 6 pi x cubed. So that's great because that means that we can work out dV by dx. And we can do that by differentiating this. So the 3 comes down to make 18 pi, and then we do drop the power down to make x squared. Okay, right, so still a lot of things to do. We've got these 3 things, which I'm sure are going to be helpful, but we need to figure out how to put them all together into one chain rule in order to get dV by dt. Okay, so I've got as much information as I can. I've highlighted them in green, and now it's about putting them together in a chain rule in order for us to find dV by dt. So let's just start with, we want dV on top, and you've got here dV by dx. So let's write that there, dV by dx, like that. Okay, well, I don't want dx at all, so I need to cancel that. So it needs to cancel by having a dx on top. And then the only other dx we have is the dA by dx. So we can put dA on the bottom, which is the reciprocal of that. Now I don't want a dA on the bottom, so I need to cancel that. So let's put dA on top. And I want a dt on the bottom, and that's lucky because we've got dA by dt. So that's all going to work out nicely. The dx's are going to cancel, the dA's are going to cancel, and we're going to be left with dv by dt. So all we need to do now is just put it all together. So dv by dx is 18 pi x squared. Now remember, this one is the reciprocal of dA by dx, so it's going to be 1 over 2 pi x. And then we're going to be timesing by dA by dt, which is pi over 20, like so. Okay, great. Now we can definitely do some cancelling here. So we can cancel out a pi, one on top, one on bottom. We can cancel out an x, like so. And we can, and that'll probably do it. That'll do enough, I think. So 18 divided by 2 is 9. And then divided by 20 is going to give us 9 over 20. There's going to be a pi on top and an x on top, so it's going to be equal to this. Now, the question says that we want to find the rate of volume at a particular given x value, so x is equal to 2. So we can just say that dv by dt when x equals 2 is equal to 9 over 20 times by pi times by x is 2. So the 2 will cancel with the 10. The 2 will cancel with the 20 and leave 10. So it's just 9 over 10 pi. And that's perfect. And that is our final answer. Oh, and I just should have checked a little bit here, but it does say write it in this form. So I would want to just put my units in there as well. So that's cm cubed to s to the -1, like that. Okay, we've got differentiation by first principles, and what I've done is I've just pulled the first principles formula from the formula book, and we're going to start by stating that f of x does indeed equal 2x cubed plus 3x. And then you can see in the formula what we need is we need f of x plus h, which is just substituting into the function x plus h where x used to be. So we put x plus h there, and that's cubed plus x, so 3 lots of x plus h. Okay, so it's a good idea just to expand that out now. Now what I'm going to do is I'm going to use the binomial expansion rather than doing a triple bracket. So the binomial expansion for a 3-term expansion has the coefficients 1, 3, 3, 1 as per Pascal's triangle. And the x's are going to start cubed, and the h's will start with h to the 0. And then we'll have the 3, and then we'll have x squared, and then h to the 1. Then we'll have the 3 again, and we'll have x to the 1 and h squared. And then the final one will have a coefficient of 1, and the x's will be to the power 0, and the h's will be to the power 3. Okay, there we go. That's probably saved us a little bit of time. And then we've also got here, of course, 3x plus h. Okay, now let's expand further. So we get 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed plus 3x plus 3h. Doesn't look like we could do any simplifying there, so that is what it is. So now I can say that the derivative function is equal to, using the formula, the limit as h tends to 0 of f of x plus h, which we now know is this very long thing here. So we'll just write this out again here. Ugh. Okay. And then minus f of x. So we need to minus the whole of this, which means that we're going to be taking away each of those two terms, like so. And then all of that needs to be divided by h. Great. Now, can we see any cancelling here? Yes, we can. There and there, and here and here. Great. So we can say then that's equal to the limit as h tends to 0 of the terms that are left, which are 6x squared h plus 6x h squared plus h 2h cubed plus 3h, all divided by h. And then we can cancel out that h. So we get a limit as h tends to 0 of 6x squared plus 6xh plus 2h squared plus 3. And then we say as h tends to 0, comma, 6xh and 2h squared also tend to 0. Hence, f dash of x is equal to what's left over if they go to 0. It's 6x squared plus 3. Perfect. We have a trapezium rule question, and you've got all the information there. And essentially it's asking us to complete the table. So we need to sub x is equal to 4 into this, which gives us the square root of 6. So on the calculator, we'll just put in the square root of 6. And then we need to give that to 4 decimal places. So that is 2.4495. Yes, it is. Okay, now it says use the trapezium rule with all values of y in the completed table to find the approximate value of the area. Okay, so we need the trapezium rule. And here it is from the formula book in all its glory. So the first thing to do is to figure out what the height is. Well, the height is the gap between the x's. So we can see here clearly that h is going to equal 2. And then the y0 and the yn are the end points. So those are here. And then the other ones are the ones in the middle, which is this one, and this one. And those you have to times by 2. Okay, so we can say then that r is equal to a half times by the height, which is 2. Open brackets, the two green ones, which are 0 and 2.8284, plus 2 lots of the blue ones, which are 1.4142, 2, and 2.4495, close brackets. And then we'll put that into our calculator. Okay, just put that into my calculator, and I've got 14.556, and that is to 3 decimal places. Perfect. Okay, now it says that we want to use the information that we've just done, the approximate value, to find an integral for this. So the first thing to do is look at the limits. So this one is between 6 and -2, so is the other one, and we have just integrated between 6 and -2. So the limits haven't changed. Perfect. So the thing that we integrated was root x plus 2, and this is half of that. Okay, so let's just rearrange that integral then to get one which is similar to what we've just got. So we can say that the integral between 6 and -2 of the square root of x plus 2 over 2 dx is the same as, well, we could take that over 2, the half, outside because it's constant, like so. And then the integral is now the exact same thing that we did the trapezium rule for. So we could say this is going to equal 1/2 multiplied by 14.5 6. Okay, so we're going to take our number and we're going to times it by half or divide it by 2. And there we go, we get 7 point, we'll give it to the same degree of accuracy as before, so 7.278 to 3 decimal places. Okay, perfect. Now, the next one, if we look up here, is just the same, but we've got +2 inside of the integral. So we can say that the next one, we're integrating between 6 and -2, 2 plus root x plus 2. And then what we can do with this one is we can split up integrals into separate parts. So because these two things are added together, we can say that it is the 2 on its own plus the root x plus 2 on its own, like so. Okay, now this one we can integrate. So 2 integrates to 2x, and we'll have to substitute the limits in. And this one is just the one we did for the Trapezium Rule, so we can use that as the approximation. Okay, so subbing in gives us 12 for the upper bound, and then you always take away the lower bound, which gives us -4. Okay, so this gives us 16 plus this to give us a total of 30.556. There we go. That is our final answer for that one. Lovely. Okay, we have a lovely looking graph, and it says that this is the function of that graph, and it's asking us to find the derivative. Okay, so what we're going to do is we're just going to pinch that and we're going to bring it down. Okay, so there is the function. So we're going to say part A. And before we do so, because it's a product rule, we're going to write u is equal to 5 lots of x squared minus 2. And we're going to write v is equal to 4x plus 9 to the power of a half. That way we can use the product rule. So when we differentiate u, well, let's just forget about the 5. What would it differentiate without the 5? It will be 2x, and then the -2 would differentiate to 0. So it'll be 2x, but then let's not forget about the 5. Let's times by the 5. So 2x times 5 is 10x. Okay, now let's differentiate this, and we're going to have to use the chain rule to do so. So we've got a bracket raised to a power. What we can do is we can bring that power down to the front. We can write the bracket out, but drop the power down by 1. So that becomes -1/2. And we must remember to times by the derivative of the bracket, which gives us times by 4. Now we've got a half times by 4 is the same as timesing by 2. So we can just write times by 2 here. Okay, great. Now the product rule tells us that we'll need to do u times by dv. So that will be u, and then we're timesing it by dv. So we're timesing it by 2. So that 5 will become a 10. Once I've written this, I'll just change that 5 to a 10. Because the 2 and the 5 times together make 10. Okay, great. So we can do that. And then it will be du times by v. So it'll give us 10x, open brackets, 4x plus 9 to the power of a half, like so. Okay, perfect. Now, what I noticed before is that we had on the bottom of the result was going to be 4x plus 9 to the power of a half, which is great here because we've got the negative power of a half, so we can put it on the denominator anyway. So that term's fine. Now this term, we don't have a negative power. But if we want the whole fraction, the whole derivative function here to have the same denominator, then we're going to need to force the denominator onto the bottom of this term. So if I do write 4x plus 9 to the power of a half, then in order to keep it balanced, to keep the fraction exactly the same as it was before, we'd have to times by the 4x plus 9 to the half on the top of the fraction as well as the bottom, and therefore that will stay the same. Okay, so now they've got the same denominator. That means that we can add the two numerators together. Okay, so we'll keep the 4x plus 9 to the power of a half on the bottom. And then here we'll have 10, again, x squared minus 2. And then here we'll have plus 10x. And you've got these two things times together. And because they're the same, we add the powers. And when we add the powers, we get 1. So it just becomes 4x plus 9. So we just get 4x plus 9 there. Perfect. Okay, and then we want to simplify the top as much as possible. So we'll expand out the brackets and see if we could do any more collecting and factorizing or simplifying. So just expanding out the brackets here. That gives us 90x. And then obviously the denominator stays the same. Okay, so we've got 50x squared on top, and we've got plus 90x, and then we've got minus 20. Okay, so much writing for these types of questions. So we're going to take out a 5. No, we're going to take out a 10. Yeah, 10 is the highest common factor there of all those terms. So we could take out a 10. So we get 5x squared plus 9x and then minus 2. Perfect. Okay, so that's 4x plus 9 to the power of a half on the bottom. Okay, I just noticed as well, perhaps I could have done that a bit quicker because I can see here that clearly both terms have a factor of 10. So perhaps I should have factorized out the 10 first rather than expanding then refactorizing. Sorry. Okay, part B says, hence find all the values of x for which the derivative equals 0. So back down here, and I write B here, and if I want f dash of x to equal 0, then that just implies that the numerator needs to equal 0, and in fact, just that bracket at the top needs to equal 0. Because if that bracket equals 0, then, well, the whole fraction would equal 0. So all we need to do now is just solve that quadratic, and absolutely fine to use your calculator here. It's a 1 mark question. So we just need to solve that quadratic, minus 2, and we get a fifth. Oh, we get minus 2. Okay, so we get x equals 1/5, x equals minus 2. Now let's just go double check to see if both of those solutions are valid or not. Aha. Look, x needs to be greater than or equal to minus 9/4. Oh, so actually, but they both are valid. And it does say here values. So that's another clue to say that they're both good. Okay, great. Now here it says that the sketch shows the curve f of x, and the curve has a local maximum at the point P. Find the exact coordinates of P. Well, P is a turning point, and it's the negative turning point, whereas the other turning point of the curve is positive. The x coordinate is positive anyway. So the the x coordinate here is negative, and we need to just substitute into the function in order to work out what the y value is. Okay, so yeah, these were the two answers for that part. And then we can say for part C, P is at x equal minus 2. So we need to find f of minus 2. So we need to substitute into that function. There we go. So I brought the function back so that we can see that we need to substitute into that. Minus 2 for x, and then minus 2, close brackets, 4 lots of minus 2, plus 9, and then to the power of a half. So I'll put that in the calculator to get that y coordinate. Okay, plop that in the calculator, and we got 10, which means that P is at the coordinates minus 2, 10. Perfect. Okay, and now let's move on to the next part that says the function g is defined as 2f of x plus 4. Find the range of g, and we're only allowed to use values that are negative. Okay, or 0. Okay, so that means that we are looking only then at this part of the graph here. So the maximum point will be P and the minimum point will be the y-intercept. So we'll need to find the y-intercept, which will be when x is equal to 0. So let's do that now. Let's just substitute in, and we'll do it up here, f of 0. So that will give us 5 lots of minus 2, and then 9 to the power of a half. So that is minus 10 times by 3, so that's minus 30. Okay, and we already know that P is at the point of height 10. Great, so that's 10 and that's minus 30. And then if we put that through the function, which is telling us to times by 2 and then plus 4, well, that's exactly what I need to do to each of these numbers. So 10 times 2 plus 4 gives us 24. And minus 30 times 2 plus 4 gives us minus 56. So we can say minus 56 is less than or equal to g of x is less than or equal to 24. Now, each of those numbers, so minus 56 and 24, you are allowed to equal those. And that's because clearly you could be P. And here you are allowed x equal to 0 for us to be minus 30, which then converts into minus 56. So overall, we should definitely put the equal to sign down to get our final answer of this. Okay, we have implicit differentiation. So for part A, we need to just differentiate the whole function. And remember, when we differentiate a function of y, we must times it through by dy by dx. So here, when we differentiate 4y squared, well, 4y squared goes to 8y, but because it's a function of y, we times through by dy by dx. 3x just differentiates to 3. Now this is a product, so we need to use the product rule. So what we're going to do is we're going to leave the blue alone, and we're going to differentiate the green. And e to the minus 2x gives us minus 2 e to the minus 2x. And then we're going to add that to us differentiating the blue, which 6y differentiates to 6, but remember we must times by dy by dx if it is a function of y. And we're going to leave the green alone, so that's just going to be e to the minus 2x. Okay, so there we go, that's the product rule. And now what we can do is just tidy up. So this will give us minus 12y e to the minus 2x. And this will give us 6 e to the minus 2x dy by dx. Now we can now collect up all of the dy by dx's on the same side, and all of the non-dy by dx's are put on the left-hand side. So we'll add this 12y e to the minus 2x over that side, and keep the plus 3. And that's quite nice because it means that both of those terms are positive on that side. And then we will keep this term on this side because it has dy by dx. And we'll move the 8y dy by dx over, so we get 8y dy by dx. You could, of course, do it the other way around and move the dy by dx to the left and the non-dy by dx to the right. That way you just get more minus signs, but it'll still be correct. Okay, so now what we can do is we can factorize. So we can say dy by dx can come out. and therefore inside the brackets we get 6e to the minus 2x, and we get minus 8y. And then that will allow us to divide through by that bracket, so that dy by dx will end up being 12y e to the minus 2x plus 3 divided by the bracket, which is 6e to the minus 2x minus 8y. Perfect. So box that up, and that is dy by dx. And then it says that for part B, the curve crosses the y-axis at the origin and at the point P. Find the equation of the normal to the curve at P, writing your answer in the form of y equals ms plus c. So if it crosses the y-axis, then we know at that point x equals 0. So what we can do is we can substitute x equals 0 into our equation to find the y-coordinate and therefore the coordinate of P. Okay, so let's do that then. So for part B, we're going to sub in x equals 0. And can I just get that in shot so that we can see the equation? Yeah, there we go, great. So that's going to be 4y squared. X is 0, so 3x goes to 0. And that's going to be 6y. And then that's going to be e to the 0. And e to the 0 is just 1. So we don't need to bother writing that. Okay. Now we can divide through by y because we know that y equals 0 is not the solution that we want, because that would be the origin. And we're not interested in the origin, we're interested in the other coordinates. So we can divide through by y without any problem. So therefore y is equal to 6 over 4 or 3 over 2. So that tells us that P is equal to x is 0 and y is 3 over 2. Okay, great. So now we're been asked to work out the equation of the normal at P. So we need to find dy by dx at P. So dy by dx at the point 0, 3 over 2 means I need to just sub in x is 0 and 3 over 2 into dy by dx. Easier said than done. Okay, so 12 lots of y, and then when x is 0, we get that e to the 0, which again is going to be 1, so we won't bother writing that down, plus 3 over, again, x is 0, so e to the x is 0, so it's just 6. No, sorry, e to the x is 1. E to the 0 is 1, is what I'm trying to say. So that's 6, as we know. And then minus 8 lots of y, which again is 3 over 2. Okay, so we should be able to do this without a calculator because that's 6, so that's 13, that's 18. So it's 18 plus 3 over 6, and that will be 4, so 12. So this gives us 21 over minus 6, which simplifies down to minus 7 over 2. Okay, so that is the gradient at P, but the question is asking for the normal. So we need to flip that over, so we can say that the normal gradient is equal to the negative reciprocal of that, which will be 2/7. And we know P, we know the coordinates, so we can just substitute in. In fact, we can, we know it's going to be y is equal to 2/7 x plus 3 over 2. Simply because the point P is on the y-axis, so therefore the y-intercept is going to be 3 over 2. Perfect. Okay, we've got parametric equations, and we've been asked to work out dy by dx. So we can do that by differentiating each of the parametric equations with respect to t, and then doing dy by dt over dx by dt. So we'll say that dy by dx is equal to dy by dt divided by dx by dt. So dy by dt, well, the derivative of sine is cos, so it's going to be 3 cos t, and the derivative of cos is minus sine, so that'd be minus 2 sine t, over dx by dt. So sine t differentiates to cos t, and here we can use the chain rule here, so we can essentially write this as 3 cos t squared. The 2 comes down to make 6. Hold up, sorry, it's a minus, isn't it? Yeah, there's a minus there, so let's not forget that. So the 2 comes down to make minus 6. And then we write cos t, and we drop the power down by 1 to make cos t to the 1. And then we need to times by the derivative of the bracket. And the derivative of cos t is minus sine t. So that turns to a plus, and we write sine t. Okay, right, some quick fire chain rule there. So once again, the power comes down, multiplies by the coefficient, keep the bracket the same, drop the power down by 1, and then times by the derivative of the bracket. And we need to show that it equals 3 when t is equal to pi. So what we need to do then is we need to substitute in when t is equal to pi. Okay. So let's do that. So it's 3 lots of cos of pi minus 2 lots of sine of pi all over cos of pi. And then, whoops, where did cos go? Whoops, what is going on? There we go, cos of pi. And then it's plus 6 lots of cos of pi times sine of pi. Now, cos of pi is minus 1, sine of pi is 0. So we're going to get 3 lots of minus 1 plus 0 over minus 1 plus 0, which is just going to give us 3, which is perfect. Exactly what we want. Okay, so now it says that the point P lies on C where t is equal to pi. So we know the gradient at that point, but we don't know the x and the y. So if we want to work out the tangent, we need the x and the y and the gradient. So the next thing to do then is to find the x and the y. So we can say at t is equal to pi, x is equal to, so that will be sine pi minus 3 lots of cos of pi squared. So once again, sine of pi is 0, but cos of pi is minus 1. Square it gives us 1, times it by minus 3 gives us minus 3. Okay, and now let's also find what y is equal to at that point. Oops. So y is equal to sine of pi plus 2 cos of pi. So that's sine of pi plus 2 cos of pi, and that will equal minus 2. Okay, great. So now we can go ahead and find the y equals mx plus c. It wants it in the form y equals mx plus c, but I'm still going to use the overpowered y minus y1 equals mx minus x1. So we're going to substitute in the y coordinate. So it's minus 2, so plus 2 is equal to the gradient, which is 3, x, and then minus 3, so plus 3. So let's expand that out to get 3x plus 9, and then let's minus the 2, and there we go, that's the equation of the tangent. Perfect. Okay, so moving on then to part C, and it says that given that the tangent cuts at P cuts C at the point Q show that the value of t for Q satisfies this equation? Well, we've got this set of parametric equations, and we're going to substitute that into the tangent line, because that will be a simultaneous equation, which will then give us the solutions to where the two curves meet, or the line of the curve, and that will be Q. Okay, so I've brought the parametric equations down, and we're going to substitute them into the tangent, thus creating a simultaneous, thus solving them simultaneously. So y is 3 sine t plus 2 cos t, and that's equal to 3 lots of x, which is sine t minus 3 cos squared t, and then plus 7. So let's expand this out, and I can see already that the signs are going to cancel, which is great because it's going to leave us just in terms of cos, which is exactly what we need to show. So we can cancel and cancel from each side, 3 sine t, and then we're going to move the 9 cos squared to this side to make it positive, and we're going to keep the 2 cos on that side, and we're going to move the 7 over, and that will make it negative. Okay, and that is exactly what we need to show. Perfect. Okay, and then the final part of the question says, hence find the exact value of the y coordinate of Q. Okay, so let's solve this equation then. That is clearly a quadratic. So we're going to go to our quadratic solver, and we're going to solve this quadratic. 9, 2, and minus 7. Okay, so therefore, if I were to have factorized it, I know the solution is that cos t is equal to 7 over 9. So if I were to have factorized it, it would have been 9 cos t minus 7, like that. And then the other factor should be, well, cos t equals minus 1 is the solution. So therefore, cos t plus 1 would have been the other factor. Okay, now the cos t is equal to minus 1. Of course, that would mean that t would equal pi, which was, of course, the coordinate of p. So that's not the one that we want. So it's this one is the one that we want. So this is good. Now, I'm not going to go ahead and find t, because that is not going to be an exact value. Okay, that would definitely be a very irrational number. So I need to use the fact that I know what cos t is, and then I need to find the y coordinate. So the y coordinate is 3 sine t, 2 cos t. Okay, so I'm going to use a triangle here. So what we're going to do is we're going to just draw a little triangle like so, and we're going to put t there. So if cos t is 9, then cos is the adjacent over the hypotenuse, which means that the opposite by Pythagoras would be square root of 9 squared minus 7 squared, which is going to give us 4 root 2. Okay, so therefore sine t is equal to the opposite over the hypotenuse. So the y coordinate that we're looking for, well, the y coordinate is 3 sine t plus 2 cos t. So it's 3 sine t plus 2 cos t. So the y coordinate is 3 lots of 4 root 2 over 9 plus 2 lots of 7 over 9. So this will be 4 over 3 root 2, and then this will be plus 14 over 9, and that is the exact coordinate. Perfect. Now, there may be a few savvy people out there that are saying, well, hold on a minute. Yes, using the triangle is great, but when you use the triangle, you must consider the fact that sine t could have been positive or negative, not just positive like I've assumed it is. Well, we can check to see whether sine t is positive or not, because we can do inverse cos of 7/9. Now that gives us an acute angle, and for acute angles, both cos, sine, and tan for that matter are positive, which is great. But you may say, well, hold on a minute, maybe that t is not the first solution for cos, maybe it's the second solution for cos. Well, yep, we could check that as well. If we do the second solution for cos, then we get more than 5, and the question said that the maximum of the range was 5, so therefore it can't be that t value, it must be the original acute one. And for acute angles, once again, sine and cos are both positive, so that's why we've used the sine t is equal to positive 4√2/9 and not negative. Okay, we've got a very tricky question here, and we know the radius and the height, which is great. It also says here that water is leaking and at a rate of 0.02 meters cubed per second. So the water, so that means the volume, is leaking at a rate, so that means dt, and because it's leaking, it's going to be negative and then 0.02. Okay, and what we're asked to find is dH by dt. So what I'll do here is I'll say that A is dH by dt. That's what we're trying to find. So I write that first. And what we know is we know dV by dt. And then if I want to make this work by the chain rule, I'm going to need to cancel that dV because that's not in dH by dt. And I'm going to need to have a dH on top like so. So the dV's cancel and you have dH over dt. Okay, so what I need to work out then, because we already know this, we know this is minus 0.02, but what we don't know is dH by dV. So I need an equation that links H and V. So let's go back up here. Okay, so the volume of this object, of the water inside the object, will be the volume of a cone, which is pi r squared h. So it'll be a third pi r squared h, of course. Okay, so that's great. Volume is equal to a third pi r squared h. Now, we can't differentiate this yet because r is variable. The radius of the water changes as the water goes up and down. But what we do know is that the radius will always be in proportion to the height. You know, the higher up it goes, the higher the larger the radius, and vice versa. And the proportion will be the same when it is full, which we do know. So what we could do is we can say that the radius divided by the height will always equal 3 divided by 5, because it will always be in the same proportion. And that way we can actually find what r is in terms of h by timesing through by h like that. So now we can go over here to our volume formula and we can swap out r for 3/5 h and then square it and then times it by h. Okay, so 3/5 squared is 9/25, times by a third is 3/25. So it's 3/25 pi, and we'll get a h squared come out of here, times by a h gives us a h cubed. Okay, great. So we can take that now and we can differentiate it, because now it's just v in terms of h, which is exactly what we want. So we're going to pick that up and we're going to bring it down here and we're going to then differentiate it. Okay, so there it is there. And this then tells us that dV by dH is equal to, well, the 3 comes down, times by 3/25 to get 9/25, and then it's pi, and then it's h squared. Drop the power down by 1. Now, remember that what we want is dh by dv, which is the reciprocal of that. So we need to flip it over, so it becomes 25 over 9, and pi and h squared are also on the bottom. Great, so now let's do 0.2 times by 25 over 9, just to see what the, so it'll be 1 over 18, but it'll be negative, of course, and then there'll still be the pi and the h squared on the bottom. So it'll be dh by dt is equal to negative 1 over 18, and that will be pi h squared. Now you can see here that the dh by dt is times by h squared, so we can multiply that up, so we can get dh by dt h squared is equal to minus 1 over 18 pi. Perfect, and that is our answer solved. Okay, great. Okay, great. It does say where k is a constant to be found as well, so I'll just put k is equal to 18 there, just to make sure I get the marks, but I'm sure I would do anyway. Okay, next it says, given that the container is initially full, express h in terms of t. Well, if I'm needed to solve a differential equation, I need to separate the variables. So for part B, I will need to multiply both sides by dt. Like so, and then that will allow me to integrate both sides. So h squared will go to h cubed and then divide by 3. And over here, this is just a constant, so when I integrate it, it just becomes a constant times by the variable, which in this case is t, plus c. Okay, great. Now, it says that the container is initially full of water, so we need to go back up here. And if it's full of water, then we just need to work out that volume. Oh, no, we don't, actually, because, of course, if it's full of water, it just means the height, which is the variable we're actually interested in, is 5. So h is 5 when t is 0. So initially full of water means t is 0 and h is equal to 5. So substituting in gives us 125 over 3 is equal to c. So therefore h cubed over 3 is equal to minus 1 over 18 pi t plus 125 over 3. Perfect. Now it does say express h in terms of t, so we're going to need to make h the subject by timesing through by 3, which gives us this and this, like so. And then we can cube root that, so we can just get h is equal to the cube root of minus 1 over 6 pi t plus 125. And that will be our h in terms of t. Lovely. Okay, and then move on to part C, and it says find the time taken for the container to empty, giving your answer to the nearest minute. Well, if the container is empty, then that will mean that the height is 0. So for part C, we need the h to equal 0 for it to be completely empty. So we can say 0 is equal to, well, if h is 0, then we can cube both sides and that will be 0. So it's just inside the cube root what we need to equal 0. So this here equals 0, which means 1 over 6 pi t must equal 125, which means t is going to equal 125 times by 6 pi. Okay, so we can do that. So we can do 125 multiplied by 6 pi, and we get, obviously, not what I'm looking for. This is what I'm looking for. So 2000 2356.2. Now let's have a look. What did it say? We want it to the nearest minute. Holy moly. Well, what unit are we talking about? We are talking about per second here. So these are seconds. You see here the rate is s. So if these are seconds, then we need to divide them by 60 to get minutes. So these are seconds, which is equal to 39.3 minutes. So to the nearest minute, it's 39 minutes. Wowza, what a beast question that was. Okay, we've got a beastly integration by substitution here, keeping it nice and tricky at the back end of the paper, as you would expect. So let's get straight into it then. And we have that x is equal to 2 sine u. So we're going to differentiate that. So dx by du is equal to 2 cos u. So therefore dx is equal to 2 cos u du. Great. Right, now let's do our limits, because we have x equals 1 and we have x equals 0. Okay, so we know x is equal to 2 sine u. So this is the same as saying 2 sine u is equal to 1, which means sine u is equal to a half, which means that u is equal to pi over 6. Because what we could do here is we could do in radian mode, so it has to be in radian mode if you're doing a trig substitution, and we could do inverse sine of a half, we get pi over 6, and it's always the principal value that you use, so no need to find like second solutions for sine in this case. Okay, now when x equals 0, we get 2 sine u equals 0, which means of course sine u equals 0, and sine is 0 at 0, so u is equal to 0. Okay, great. So those are our two limits. We've got dx. We know what x is, so we should be pretty good to substitute in now. So we're going to say I is equal to, so that's the integral, and we're going to rewrite it now with limits of, what do we say, pi over 6 and 0. And then on the numerator, we have, you can see up here, 3x plus 2. So that will be 3 lots of 2 sine u plus 2. And then on the denominator, we have 4 minus x squared to the power of 3 over 2. So we've got 4 and then minus x squared. So just on the side here, obviously if x is equal to 2 sine u, then x squared will be equal to 4 sine squared u. So we've got minus 4 sine squared u, and that is to the power of 3 over 2. And we need to multiply by dx, which is 2 cos u du. Okay, great. Now, let's look at this denominator. Because we know, of course, our most important trig identity is sine squared plus cos squared is equal to 1. So we can say that cos squared u is equal to 1 minus sine squared u. We can scale that up by a factor of 4 as well. So we get exactly what is underneath that, inside that bracket. Okay, great. So we can do equal sign again. We can put our limits, and we can, on the top, I guess we can expand that out to get 6 sine u plus 2. And then on the denominator, we've now got 4 cos squared u, which needs to be raised to the power of 3 over 2, which is the same as, well, doing the square root and then cubing, because the 2 on the bottom of the power means to square root, and then the 3 on the top means to cube. And then we need to put that in brackets because we're going to times that through by 2 cos u du. Okay, great. So now we can just do a little bit more simplifying. And on the denominator, when we square root 4 cos squared u, that gives us 2 cos u, and then we need to cube that. And I'm not going to multiply this out because I can see here that the 2 cos u is going to cancel with one of the 2 cos u's on the bottom. So that's going to go, and that's going to decrease that power down to a 2. Okay, great. So now we can write this as 6 sine u plus 2 over, and then maybe it is a good time to expand that out now because that's 4 cos squared u du. And what we have here is we've got on the top, we've got 2 parts here. We've got 2 terms on the top, and we've just got over a common denominator. So we can split that up. And the thing that we are trying to aim for is split up into 2 terms. So it makes sense now to split this up into 2 terms. So this is 3 over 2 because 6 divided by 4. And then what have we got here? We've got a sine u over a cos squared u. So that's the same as writing it like this. And that'll become apparent as to why I've done that in a second. Okay, and then the next term is going to be 2 divided by 4 is a half. And of course, we're going to have cos squared u on the bottom. Okay, great. So now we are finally ready to write it exactly how we've been asked. And that is 3 over 2 sine over cos is tan, times by 1 over cos is sec. And then here we've got a half of, and then cos squared on the bottom means sec squared on top. Perfect. So that's what we've been asked to do. And that's good. And now the next part of the question, I believe, is just asking us to integrate it. Okay, so we can do that. Because these are actually relatively standard integrals. They're just reverse of some of the standard derivatives, because we know that sec differentiates to sectan. Again, that's in the formula book. So the integral of sectan will be sec. So this integrates to 3 over 2 sec u. And we know that the derivative of tan is sec squared. So therefore the integral of sec squared is tan u. Perfect. And then we have these limits once more. Okay, so now we can substitute in the limits. So for the first one we get root 3. And then the next one goes into the calculator and we get this. Perfect. And then we'll be minusing, and then when we sub in 0, well, cos of 0 we know is 1, so sec of 0 is also 1, so we just get 3 over 2, and tan of 0 is 0, so we don't get anything there. Okay, so add those two together, it gives us 7 root 3 over 6, and then minus 3 over 2 for our final answer to that beastly substitution. Lovely. Okay, question 20, the final question, parametric integration with some partial fractions thrown in for good measure. Okay, so we need to find the area, and it's a parametric equation, so we need the parametric integration equation, which is just integral of y dx over the parameter variable, which is t. So dt and then times by dt, like so. Okay, great. So let's start with the fact that x equals ln of t plus 2. And then let's differentiate that. Well, we can say that dx by dt is equal to, by the chain rule, this gives us 1 over t plus 2, like so. So our integral then becomes y is 4 over t squared, and then we're multiplying that by 1 over t plus 2, and then dt, like so. We also need to sort out the bounds, the limits. Okay, so let's do that over here. So we're integrating between these two limits here, and those are limits in terms of x. So that's x equals ln 5 and x equals ln 3. Now we know that x is also ln of t plus 2. So if that equals ln 5, then clearly you can see that t must equal 3. So we can say t equals 3 there. And then when x equals ln 3, we get that, again, if x is ln of t plus 2, and if that equals ln 3, then t clearly equals 1. Okay, so we've shown what the limit should be. So we can just put those in there, 3 and 1, and then we can just push them all together to get 4 on top over the two denominators times together, as we would do when times fractions. And there we go, that is our integral. Okay, great. So now it's asking us to find the exact area, and we need to integrate that by partial fractions. Okay, so let's say that 4 over t squared t plus 2 is going to be the same as a over t squared plus b over t, because remember we have a repeated root, you have to do it over the squared and the non-squared, and then finally plus c over t plus 2. Then we multiply through by that denominator of t squared plus 2, and that will clear the left hand side. And then if you're timesing through by t squared, the t squared at the bottom clears, but we also times through by t plus 2. And if you times through by t squared, then one of the t's are going to clear. So there's going to be a t left over and the t plus 2. And then as well here, we're going to clear the t plus 2. So there'll be the t squared left over. Okay, then we pick t values that are going to eliminate some of these brackets. So we're going to let t equal 0. And that gives us 4, of course, on the left-hand side. And then if we sub in t is 0 in here, we get 2a. And t is 0 will knock out this term, and it will knock out that term. So we're left with 4 equals 2a. So that implies that a is equal to 2. Okay, then we let t equal minus 2. And again, the left-hand side will still be 4. And when t is 2, when t is minus 2, that cancels, but the last term remains, and we get c lots of minus 2 squared. Minus 2 squared is 4, so 4 equals 4c, so c is equal to 1. Okay, and then to find the final letter, you could just sub in any number at all. And we've already subbed in t as 0, which is the easiest number to sub in, so let's just sub in t equals 1. Okay, so again we get 4 on the left hand side, and that'll give us 3a. And when t is 1, we get 3 times 1 times b, so 3b, and we get plus c. at the end. So 4 is equal to 3a is 3 times 2 to make 6, plus 3b, which we don't know yet, but c is 1, which we do know. Okay, so that is 7, minus it over gives us minus 3. So this gives us 3b equals minus 3. So b is equal to, of course, minus 1. Okay, great. So what we were integrating between 3 and 1 was 4 over t squared t plus 2. But now that is equivalent to us integrating the partial fractions. A is 2, so it's 2 over t squared. B was minus 1, so we could put minus 1 over t. And c was 1, so we just put plus 1 over 2t. T plus 2, sorry. And that is dt, of course. Whoops, should have put dt here. Great. Okay, right, so integrate each of these then. Well, this one we can write as 2t to the minus 2, like so. And then we just simply increase the power by 1, and then we divide by the new power. Perfect, so that will do. This one here is, well, 1 over t integrates to ln t. So we get minus ln t. And here 1 over t plus 2 integrates to ln of t plus 2. Okay, and that's always going to be the case. If the denominator's derivative is the numerator, then it's going to integrate directly to ln of that denominator. And we've got 3 and 1 that needs to be substituted into there. Okay, great. So let's substitute in. So we're going to get minus 2 over 3 for the first term. We're going to get minus ln 3, and we're going to get plus ln of 5. Okay, so that is for the upper bound, and then we're going to subtract the lower bound. So when t is 1, that gives us just minus 2. And then ln of 1 is 0, so we can miss that one out. And then here we're going to have plus ln of 3. Okay, let's write them all out then without any brackets, like so. And we've got minus 2 is plus 2, and then we've got minus ln 3, like so. Okay, so let's just collect together the constant term, well, not the constant, the non-ln terms. So 2 minus 2/3 is 4/3. And then in terms of the lns, we've got positive 5, so we can put that on top. And then we've got a negative 3 and another negative 3, so they can go on the bottom because of log laws. If you are subtracting a ln, you need to divide by that input. So we've got positive 5 and 2 negative 3s, so it's going to be 5 over 3 and a 3. Okay, great. So let's finish this off then. It's 4/3 plus ln of 5 over 9. Perfect. And that's a wrap. I hope you enjoyed that. I hope you had as much fun doing it as I did making it. And if you did and you found it was helpful, then I would recommend checking out my revision session that I'm going to be running on the 7th of June. Now, tickets have sold out, but you can still purchase access to the recording of the session and all the resources, including all written solutions to all 40 questions and video solutions to all 40 questions too. So the session runs as follows. I've compiled 2 more predicted papers for the session. Students get to vote on what questions they want to see, and then I do those questions live across 3 hours of teaching, giving out as many exam tips as I go through. So if that is something that is going to interest you, then click the link in the description. And also my paper 3 session has a handful of tickets left, so if you need some help with stats and mechanics, well, that's your place to go. Okay, all the best for your final exams. Let me know how they go. Good luck. Bye for now.